All right, so we've talked about addition and subtraction with matrices, and we're going to talk about multiplication next. And this is where things start to deviate from what you know about real numbers, because there's actually different types of multiplication with matrices. But this particular type of multiplication, called scalar multiplication, is pretty straightforward. We're just taking some real number, some single real number C times a matrix. So, you know, so if we have something like, let's say 2 times A, it just means A plus A, just like it does with real numbers. If we have 5 times B, right, that's just the same as B plus B plus B plus B plus B, right? It's B 5 times. So scalar multiplication is pretty straightforward because all we're going to do is basically take each element in the matrix and multiply by that scalar. The scalar being this real number that we're multiplying by. All right, so we're going to take a look at example 6. This is we're starting to see the beginnings of some algebra with matrices. So we're asked to find a matrix X that satisfies this matrix equation. So 2x plus b equals 3a. All right. Well, so we want to find a matrix, right? This looks like an algebraic equation, except that these things, x and a and b, are matrices. But we're given what a and b are, so let's just start by substituting those matrices in. So we have 2x, x is what we're trying to find, plus b, and b is 3, 2, oops, hang on, I'm going to make that a little bit so they don't look like separate numbers. 3, 2, negative 1, and 2. That's our B matrix. And we're told that that's equal to 3 times A. 3, 4, minus 1, 2. All right. Well, let's first of all do this scalar multiplication. All right. I'm multiplying this matrix times 3, right? Which is essentially just taking that matrix and adding it to itself 3 times. So, but I'm just going to take each element in the matrix and multiply by 3, right? So I'm going to get 3 times 3 is 9, 3 times 4 is 12, 3 times minus 1 is minus 3, and then 3 times 2 is 6, all right? So there's 3 times A. All right, I'm just going to copy this down as is. 3, 2, minus 1, 2. All right, now I want to solve for x. So just like you do in algebra, I can subtract from both sides. I can subtract the same thing from both sides. So if I subtract this matrix B from both sides, then what I'm left with is 2x on the left-hand side, and then I have 9, 12, minus 3, 6, and then minus 3, 2, minus 1, 2. All right, so I have to subtract those matrices. And what do I get? I get, well, let me just put it over here. So 9 minus 3 is 6, 12 minus 2 is 10, negative 3 minus a minus 1. So that's basically negative 3 plus 1. So that's a negative 2. And then 6 minus 2 is 4. All right, so there's the sum of, or the difference of those two matrices. And now I'm just going to multiply both sides by 1/2. Right? Multiply, and I'm going to multiply this by 1/2. Okay? So then I'll get x. X is equal to 1/2 of this matrix. So it's a scalar multiple of this matrices, 1/2 of this matrix. So we end up with 3, 5, minus 1, and 2, just taking 1/2 of each element. Okay? So there's a matrix. There's a matrix that will satisfy that equation. If we were to plug it back into the original equation, take it times 2, and then add b to it, we should get 3 times a. All right? So there's our solution. All right, so that's all I have for you today for the lecture, and you can look ahead at the discussion questions, and I'll meet you in class.